So example number 3, a continuous random variable x has probability density function defined by f of x is kx when x is in the interval between 0 to 1, and it is k into 2 minus x when x is in the interval 1 to 2 or 0 elsewhere. Then you'll be told to determine Roman 1 the value of k, Roman 2 the mean, Roman 3 the variance, and Roman 4 the probability that x is between the intervals 1 over 4 to 3 over 2, isn't it? So first of all, you need to know that the probability of a random variable x, of a continuous random variable x between the limits a to b is given by, you are integrating from a to b of f of x dx. And when you integrate this, you get the whole range of a probability measure, which is 1. So if you're told to determine the value of k, then it means, Roman 1, when we want the value of k, then when we are now looking for the probability that x is between the interval, whether it is equals to or just less than like that, when x is between that interval is given by, you are integrating from a to b of f of x dx, which is equals to 1. Then you substitute, isn't it? So the first function f of x, for the first interval from 0 to 1, you see, from 0 to 1, we take f of x to be kx. You see that? Then from 1 to 2, we take f of x to be k into 2 minus x. So we have from the interval from 0 to 1, the function f of x, from 0 to 1, the function f of x is just kx. So k is a constant you factorize outside, isn't it? So k into x dx. Are we together? Then it is plus from the interval 1 to 2, from the interval 1 to 2, the function f of x is defined as what? K into, so k is a constant you take outside, then you move the 2 minus x dx, isn't it? And that should give you 1. You see that? So the function f of x has different definition at given different intervals, isn't it? So from 0 to 1, we take f of x to be kx, which of course we factorize a constant outside. From the interval 1 to 2, we take the function f of x to be k into 2 minus x. So you factorize out a constant, isn't it? So start with this part. K is outside. When you integrate x, what do you get? You get x squared over 2. Then the limit there is 0 to 1. Then plus, here k is outside. When you integrate 2, what do you get? So when you integrate 2, you get 2x. Then we have minus. When you integrate x, you get x squared over 2. Then your intervals there is 1 to 2, isn't it? Then after that, the whole of this is equals to 1. So start with this. When you substitute the value of x in this first bracket, what do you get? The upper limit, when you put x to be 1, it is 1 squared over 2. A half, isn't it? It will be a half minus the lower limit. When you put x to be 0, it is 0 squared over 2 will be 0. So you are done with this first part. Then it is plus k into the first part here minus the lower limit to be equals to 1. So start. Where the results, when you put 2, what do you have? 2 times 2 is 4. Then here is 2 squared is 4. 4 divided by 2 is 2. So it's like you have 4 minus 2, isn't it? Which is 2. So the upper limit is 2. Then the lower limit, you put 1, isn't it? So 1 times 2 is 2. 1 squared is just a half, isn't it? So 2 minus a half is 3 over 2, isn't it? So you substitute the upper limit minus lower limit, isn't it? So what do we have here? A half minus 0 is just a half. So a half times k, that is a half. A half k, isn't it? Then here, 2 minus 3 over 2 is a half. Because 2 is like 4 over 2. 4 over 2 minus 3 over 2 is 1 over 2, isn't it? A half times k you get plus a half k. Then it is equals to 1. So what is the value of k? Half k plus half k is k. To be equals to 1. So it means our constant k is 1. You have found the value of k to be 1. Are we together? Now, after getting the value of k to be 1, where there is k, you now substitute it with 1, because we now want to use it to get mean variance in that given probability, isn't it? So where there is k here, we put 1, meaning silent. Where there is k here, we put 1, but 1 is silent. So you see, we have now substituted the value of k, isn't it? We now know the definition of a function f of x when k is 1 is that. So it is now what we use to get the mean variance and that probability, isn't it? So go to part 2. What do they want in part 2? Mean. The mean. So in part 2, they now want you to determine the mean. So the mean, Roman 2, we said the mean is the expected value of? Is the expected value of x, isn't it? So it means the mean you are integrating from a to b, x, f of x dx, isn't it? X times f of x. Are we together? So what is the mean? The first one will, the function f of x is x between this interval, isn't it? Meaning if you have the interval from 0 to 1, we are going to have x, f of x is what in that interval? From 0 to 1, f of x is what? Is x, so it is x into x dx, x f of x, meaning f of x is x between interval 0 to 1. Now you see that? Then dx, then plus x f of x between the interval 1 to 2. So between the interval 1 and 2, we are going to have x f of x. So what is f of x between the interval 1 to 2? F of x is 2 minus x. So you see, you substituted x f of x. This is x f of x between the interval 1 to 0 to 1. You see that? Then here, this is x f of x. This is the value of f of x between the interval 1 to 2. Meaning f of x has different definition with the different intervals. Are you seeing that? Are we together? So you now write it in a manner which you can integrate, isn't it? So write it in a form which you can integrate x times x, x squared dx, isn't it? Then plus, integrate from 1 to 2, x times 2, 2x minus x times x, x squared dx, isn't it? So what is important? You must put the definition of f of x in a given interval, isn't it? Are we together? Is that okay? Good. So start with this first one. If you integrate x squared, you get x cubed over, then your interval is 0 to 1. Are we together? Then it is plus this other one. If you integrate 2x, see 2x squared over 2, isn't it? So it means 2 will cancel with 2, isn't it? Are we together? Yeah, you just remain with x squared, isn't it? Then minus, if you integrate x cubed over 3, then your intervals are 1, 2. Are we together? So if 2 cancels with the 2, here you remain with x squared, isn't it? You remain with x squared. So start substituting. The first part is this. Substitute upper limit minus lower limit. When x is 1, you get 1 cubed over 3. When x is 1, you get a part, isn't it? Then minus when x is 0, you get 0, isn't it? So you are done with this part. Then you move to the other part, plus. When x is 2, 4 minus 2 cubed, 8 over 3. 4 minus 8 over 3 is 16 over, use calculator. 4 minus 8 over 3. 4 is the same as, it is not 16. Yeah, 4 is the same as 24 over 3. 24 minus 8 over 3 is 16 over 3. Have you done it? Good. Then it is minus, when x is 1, so it is going to be 1 squared, it's just 1. 1 minus a third. 1 minus a third is 2 over 3. Because 1 cubed is 1 over 3. So this is 1 minus 1 over 3. 2 over 2 over 3. So have you seen? The next thing is just upper limit minus lower limit plus upper limit minus lower limit, isn't it? So what do you get? A third minus 0 is a third plus 16 over 3 minus 2 over 3, you get 14 over 3, isn't it? So can you now add 1 over 3 plus 14 over 3? You get? You get 5. You get 5. So recheck again, recheck. Start here again. Look here. When x is 1, we have a third minus 0, that is a third, isn't it? then from this, for this interval, this is x squared. So when x is 2, you get 4 minus 8 over 3, isn't it? 4 minus 8 over 3 was 4 minus 8 over 3 in mixed fraction. In a proper fraction is 4 over 3. 4 minus 4 over, this is 4 minus 8 over 3, isn't it? X squared is 4 minus 8 over 3. This is 2. 4 minus 8 over 3. 2 cubed is 8 over 3. 4 minus 8 over 3. It is 4 over 3. Are you see? It is 4 over 3. So that is where the problem is when we wrote 16 over 3. Because I'm saying the mean is not 5. You see the x value is ranging from 0 to 2. The mean must be a number between 0 to 2. Are you seeing where the problem is? That's why I had to go back, because you will always see a problem when you mess up in these things. Are you seeing that? Are we together? So you are seeing this one minus this, it was not 16 over 3. It was 4 over. Then when it is 1, what do you get? 2 over. This is 1 squared minus 1 cubed over 3, meaning 1 minus a third. 2 over 3. So this is where the situation is. The mean cannot be that. Are we together? So here we had a third, then plus 4 over 3 minus 2 over 3. So you get 2 over 3. 2 over 3. So what do you get? A third plus 2 over 3 is what?
1.
The mean is 1. Are you seeing that? The mean is 1. When you make a mistake, you will always see where the problem is. The mean is 1. Because you can see the x value is starting from 0 and ending at 2. Meaning the mean must be a value of x which is between 0 and 2. Are you seeing? Are we together? So that moment when you are getting 5, you want to go back and check your substitution. That's why I do say you must use a calculator. Okay? You must use a calculator when you are doing this. Are we together? So we found the mean is equal to 1. So let us go to the variance. Let us go to the variance. After the mean, we are now going to the variance, Roman number 3, isn't it? How do we get that? The variance. Now, before you get the variance, you must get the expected value of x squared. Are we together? You must get the expected value of x squared. So Roman 3, when you are looking for the variance of x, if you are dealing with the discrete data, can you recall from discrete data, you are getting the variance to be summation of fx squared over summation of f minus the mean minus summation of fx over the mean squared, isn't it? Are we together? Now look at this with the theory of expectations. The mean, this was discrete, but here we're dealing with continuous. I want to show you the relationship, isn't it? This mean here was given by the expected value of x, meaning this expected value of x squared. Are you seeing? So if it is expected value of x, we add x. So it means here we have x squared. So if this is x squared, meaning the whole of this is expected value of x squared. Are you seeing the variance? So the variance is expected value of x squared minus the mean squared, because expected value of x is the mean. Are you seeing? Are we together? So if here is x, then the whole of this is the expected value of x, but the whole of it is squared. Then here, when it is x squared, it is expected value of x squared. So the variance is going to be given by expected value of x squared minus the mean squared. The mean is the expected value of x, isn't it? So expected value of x we've already found, it is the mean. Are you seeing that? Are we together? So before we get the variance, we must get the expected value of x squared. Are you seeing? So for you to get the expected value of x squared, you simply integrate from the limits, then you put it is your x squared f of x dx, isn't it? You see, when you are looking for the expected value of x, it is x f of x. Are you seeing? But now when it is expected value of x squared, it is x squared f of x. Are you seeing that? If it is expected value of x cubed, it is x cubed f of x. Are you seeing that? Are we together there? Yes. Good. So it means the expected value of x squared is x squared f of x. Then you start substituting. F of x has different definitions. Meaning between 0 to 1, f of x is just x. Are you seeing? Are we together? So start. The first definition, this will be what? You are integrating from 0 to 1. From 0 to 1, then we have x squared f of x. And f of x is what? Is x between 0 to 1, then you are dx, isn't it? Then plus between the interval 1 to 2. Are you seeing that? Between the interval 1 to 2, then you have your x squared f of x. But what is f of x between this interval? F of x is 2 minus x. 2 minus x, then dx. So you see, you have x squared f of x. This is x squared f of x between the interval 0 to 1. This is x squared f of x between the interval 1 to 2. Meaning f of x has different definition in this given probability density function at given intervals, isn't it? Are we together? So start, simplify it, the form you can integrate. So this is from 0 to 1, x squared times x. You get x cubed dx, isn't it? Then you move on, go here, then plus you are integrating from 1 to 2, x squared times 2, 2x squared ahead, minus x squared times x cubed dx. Good. So start integrating. Start integrating the first part here. What do you have? If you integrate x to power 3, you get x raised to power 4 over 4, isn't it? The interval 0 to 1, isn't it? Then it is plus, start here, if you integrate 2x squared, you get 2. It is now x cubed over 3, isn't it? Isn't it? Then it is minus, if you integrate x cubed, it is x raised to power 4 over 4. Remember, constant is just on its own. What we are integrating is x squared, isn't it? Which you get x cubed over 3. X raised to power 3, x raised to power 4 over 4. Then you put the limits is from 1 to, the limits is from 1 to 2. Now, from there, can you now substitute? Substitute. I start with this first one. Remember, we were looking for expected value of x squared. So this first one, when x is 1, what do you have? 1 over 4 to be the upper limit. When x is 0, you get 0. So you are done with this part, isn't it? You go to the other part, plus, start with the upper limit. When x is 2, 16 over 3. 16 over 3 minus 2 raised to power 4 is 16 over 4. 16 over 4 is 4. So it means you have 16 over 3 minus 4. What do you get? 16 over 3 minus 4. 4 over 3 as the upper limit. Then lower limit, when x is 1, here is 2 over 3, isn't it? Minus 1 over 4. So 2 over 3 minus 1 over 4, when x is 1, what do you get with the lower limit? 2 over 3 over 5 over 12. So can you now give me the value? 1 over 4 minus 0 is 1 over 4. Plus 4 over 3 minus 5 over 12. 4 over 3 minus 5 over 12. 11 over 11 over 12. So if you add the 2, what do you get? 7 over 7 over 6, isn't it? So that is the expected value of x squared. But what are we looking for? The variance of x, isn't it? So we've seen the variance is the expected value of x squared minus the mean squared. Are you seeing? It is the expected value of x squared minus the mean squared. And what did you get to be the mean? 1. So can you start substituting? Expected value of x squared you found is 7 over 6. Then it is minus the mean squared. 1 squared, isn't it? You get the answer to be? 1 over 6. 1 over 6, which is what in fraction? In decimals, I mean. 0.167. 0.167. 0.167, like that. It is 0.16666. Good. So that is the variance of x. So you have found the variance to be 0.167. What else do you want? The probability that x is between 1 over 4 to 3 over 2. Are we together there? We want the probability that x is between 1 over x is between 1 over 4 and 3 over 2. Are we together there? Good. So let us go here. What do we have? That is Roman 4. Are we together? Okay, Roman 4. What is the probability that x is between 1 over 4 and 3 over 2? Okay? So, I want you to pay attention here. What did we say is the probability? The probability that x is between A to B, you just integrate f of x within those limits, isn't it? Are we together? So look here. When you want this probability, meaning we are integrating from 1 over 4 to what? Now look, the first value of x, go there and see. You are supposed, for you to get this probability, you are supposed to integrate from A to B of f of x dx. That is how to get a probability, isn't it? But remember, the whole probability is not 1 because you are not dealing with the whole interval. You are just taking part of it from a quarter to 3 over 2, isn't it? Are you seeing that? Meaning you are going to get part of it. Are we together? Now look here. If you start from 4, what is f of x? F of x is x when the range is from 0 to 1. Are you seeing? Meaning for you to start from 1 over 4, you start from 1 over 4 and you reach 1. You cannot go past 1 because when you reach 1, f of x is x. Are you seeing? Are we together? Meaning for you to move the probability of 1 over 4 to 3 over 2, you start from 1 over 4 to 1. Then from 1 over 4 to 1, what is f of x? Is x, meaning f of x is x dx, then plus, you now proceed from 1, because you can see from 1 to 3 over 2 is in another level. Let me see. You now proceed from 1 to 3 over 2, meaning you don't reach 2, you only reach 3 over 2 is what they want, isn't it? You proceed from 1 to 3 over 2, then from 1 to 3 over 2, f of x is what? Is 2 minus x dx. So you see you are integrating from A to B of f of x dx. Are we together? Look at the limits. The limit is from 1 over 4 to 3 over 2. Is that okay? So in the first part, look here. The first part, the limit is from 0 to 1. Meaning for you to move from 1 over 4 is somewhere here, past 0, isn't it? You can only reach 1 when f of x is this. You cannot go past 1. Are you seeing? Then now when you start from 1 will now move up to 3 over 2. Meaning from 1 to 3 over 2, f of x will be this. But from a quarter to 1, f of x is x, the upper limit, the upper definition, the first definition, isn't it? Then now from 1 to up to 2, but you are not reaching 2. You are told to reach 3 over 2. Are you seeing that? Are we together? You've understood that? Good. So after you've understood that, we just now integrate f of x dx within those given intervals. Start here. If you integrate x, you get x squared over 2. Then put your limits is from 1 over 4 to 1, isn't it? Then plus, if you integrate 2x minus, if you integrate x squared over 2. Then the limits is from 1 to 3 over 2. Are we together? So start substituting. I start with this one. When x is 1, so you get 1 squared over 2. Meaning the upper limit will be a half, isn't it? Then you go, when x is a quarter squared divided by 2, calculator. A quarter squared divided by 2, I can see this 1 over 32. What have you found? 1 over 32, yes. You are done with this part, isn't it? Then it is plus, here, start, when x is 3 over 2. 2x, 2 times 3 over 2 is 3, then it is minus 3 over 2 squared divided by 2. That is 9 over 8, isn't it? What have you found? 3 over 2 squared is 9 over 4. Divide by 2. 3 over 2 squared thing you use the calculator. You are only squaring 2, you are not squaring 2. Use the calculator for engineering mathematics. In bracket 3 over 2. 3 over 2. 3 over 2, if you square, what do you get? That calculator is not for engineering mathematics, my friend. What are you getting there? 9 over 4. Then if you divide by 2, what do you get? 9 over 8. Can you go for the right calculator? Tafadhali. Okay? 9 over 8. If you are not going for the right calculator, can you use that calculator appropriately? Okay? So what do you have here? This was 3. So 3 minus 9 over 8. 15 over? 8. 15 over 8. So there you have 15 over 8. Then minus lower limit when x is 1. You will have 2 minus. When x is 1, where there is x, you put 1. So this is 2. 1 squared is 1. So this 2 minus half is 3 over 2. Now start. Here. A half minus 32. A half minus 1 over 32. 15 over 32, then it is plus 5 over 8 minus 3 over 4. This is 15 over 8 minus 3 over 2 you have? 3 over 8. 3 over 8. So can you add 15 over 32 plus 3 over 8? 27 over 32. That probability must be between 0 and 1. So you can see that one is right, isn't it? Are we together? Are we together? Good.